All right, so are you ready to kind of like really stretch your mind? Today we're going deep, deep into this world of space-time, relativity, all those like cosmic mysteries that just make you question like everything.
Yes, pretty wild, right?
Yeah. And you know what's cool about this deep dive? Like what we're using to guide us? It's a discussion that takes like incredibly complex science and makes it, well, surprisingly accessible. They use a lot of like pop culture stuff to get the points across.
It's amazing how much pop culture like reflects these deep scientific concepts, right?
Yeah. So, okay, like picture this, right? A universe where space and time, they're like woven together. And get this, your movement through one like actually impacts the other. Crazy, huh?
Yeah, we kind of think of ourselves, like moving through space, but really we're navigating this like four-dimensional fabric.
Four-dimensional.
Yeah. It's called, well, space-time. And every step we take, every second that ticks by, we're traveling through both space and time at the same time.
Okay, so like let's break down this four-dimensional universe
Yeah.
thing, right?
Yeah. Sure. I get like space has three dimensions, like length, width, height.
Right, right.
But how does time fit into all of this as like a fourth dimension?
Okay, so think about this, right? To pinpoint an event, like you need more than just its location in space, right?
Mm-hmm.
You also need to know when it happened.
Okay.
And that when is the fourth dimension time. It's not like separate from space. It's like woven together with it.
So it's not just that like time exists in space, but time is like a part of space.
Yeah, yeah, exactly. They're interconnected, space and time. And here's the really wild part. This interconnectedness, it leads to some uh pretty mind-bending consequences.
Like what?
Well, for example, right? The faster you move through space, the slower time passes for you.
Whoa, wait, really?
Yeah, compared to someone who is like stationary.
That's like straight out of a sci-fi movie.
Well, it's more than just like science fiction, the movie Interstellar, you know that one?
Oh, yeah, yeah. They actually they depicted this whole concept of time dilation pretty accurately.
Oh, okay, yeah.
Remember that scene, where they land on that planet
Uh-huh.
near a black hole?
Oh, yeah, 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 where they're like there for a few hours, but when they get back to the spaceship, like decades have passed.
Exactly. That's like a really dramatic illustration of how gravity actually warps space-time.
Oh, wow.
The stronger the gravity, the slower time flows.
That is crazy. And to think, like, people were pausing the movie to debate, like, the science of it all.
Oh, no, right?
It really shows you how much this idea, like, captures people's imaginations.
Yeah, for sure. And speaking of mind-boggling concept, there's another aspect of the universe that like raises even more profound questions. It's this idea of the Goldilocks universe.
Oh, I've heard of that. It's like
Yeah.
the universe is, like, perfectly set up for life to exist, right?
Exactly. Imagine you're baking a cake, right?
Okay.
You change the amount of flour or sugar, even just a little bit.
Yeah.
The cake won't turn out right.
Right, right.
The universe is kind of like that. The fundamental constants, things like the speed of light or the strength of gravity, they have to be incredibly precise. I mean, incredibly precise for stars, for galaxies, ultimately for life to exist.
So is it just luck that our universe has all the right ingredients, like, perfectly measured out?
Well, that's the big mystery, isn't it? Why is the universe so finely tuned? It's a question that fuels so much debate, so much exploration. I mean, some scientists, they see this as evidence for like a grand design,
Right.
while others believe it's just, a cosmic coincidence.
It's a real head scratcher for sure. Like, it makes you wonder. Okay, so let's shift gears a bit. You can't talk about space-time without talking about, the genius who first cracked the code.
You mean Einstein, right?
Yeah.
Oh, absolutely. Einstein's theory of special relativity, it completely changed like our whole understanding of space, time, and gravity. And it all started with him as a teenager, picturing himself chasing a beam of light.
Wow. So, like, sometimes the biggest breakthroughs come from, like, the simplest questions.
Right. A sense of wonder, that's all it takes.
Yeah, yeah.
So from that thought experiment, Einstein, he realized that the speed of light, it's constant. It doesn't matter how fast you're moving. It's like a cosmic speed limit. It's built into the fabric of the universe.
But how does that even make sense? Like, if I'm on a spaceship going at, like, half the speed of light and I turn on a flashlight, wouldn't the light from that flashlight be traveling at, like, 1.5 times the speed of light?
I know, that's what our everyday intuition tells us, but it turns out our common sense doesn't really hold up at those speeds. What actually happens is that time itself slows down for the person on the spaceship.
Oh, well.
so that the speed of light remains constant for everyone.
It's so counterintuitive.
It is, it is. But it's been verified, through so many experiments. One of the best demonstrations of this is something called the muon experiment. Have you heard of muons?
I don't think so.
Okay, so muons, they're these subatomic particles, and they're created up in the upper atmosphere, and they have a very, very short lifespan.
Okay.
They shouldn't be able to reach the Earth's surface, but they do.
So is that because, like, time slows down for them because they're traveling so close to the speed of light?
Exactly. From their perspective, their journey is much shorter, so their lifespan is long enough for them to reach the Earth.
So even, like, subatomic particles experience time dilation.
They do. And speaking of bizarre consequences of special relativity, you know that example with the 8-foot car?
Oh, yeah, fitting into the 5-foot garage?
Yes. Classic illustration of length contraction. It sounds impossible, but according to Einstein's theory, an object moving at high speed will appear shorter in the direction it's moving.
Wait, so the car actually shrinks?
Not exactly, no. It's more accurate to say that the measurement of its length, it changes from different frames of reference. You see, from the perspective of someone standing still, the moving car appears shorter. But, get this, from the car's perspective, it's the garage that appears to have shrunk.
So it's like reality is, like, shifting based on your point of view.
In a way, it is, and it's a direct result of the fact that space and time, they're not absolute. They're relative to the observer's motion. And, all of this revolution in our understanding of space and time, it builds upon the work of James Clerk Maxwell. You familiar with him? His equations on electromagnetism, they were a key inspiration for Einstein.
It's amazing how science, like, builds upon itself.
It really is. It's this continuous journey of discovery. And with each new insight, we peel back another layer of the universe's mysteries. What's important is that we embrace the unknown. We keep asking those what-if questions and never lose that sense of awe.
That's so true. So for our listeners out there, here's, like, a question to ponder. What if you could travel at the speed of light? What would time feel like? Would it stop completely? Would it be something we can't even, like, wrap our heads around? And if the universe is really so finely tuned for life, does that, like, point to a grand design? Or is it just an incredible cosmic coincidence?
Yeah.
The answers, they might still elude us, but the pursuit of those answers, that's where the real excitement is. So keep exploring, keep questioning, and maybe one day, we'll unlock some of the universe's biggest secrets.
I can't wait.
Me neither.
There's so much more to discover.
I know, right?
Yeah.